right, so coordinate geometry. So the grid below is known as the Cartesian coordinate system or the rectangular coordinate system. I'm like 80% sure that becomes because Rene Descartes defined it. There's a joke in the culinary arts that, you know, the French invented fire, right? um, because it deals with the culinary arts. It's just whoever names it, right, first gets to keep it. You'll see other coordinate systems. Most particularly, you'll see a polar coordinate system. And so polar coordinates are different in the sense that you have a distance from the origin as r, and then some theta as the angle from that. And so when you look at a map, they're almost always kind of done in kind of Cartesian style, where it's just, you know, this is your distance and you go from there and all this other stuff. But honestly, most people use a polar system in their head a lot more, where the distance and r usually in how long it takes you to drive there, and the direction, and your theta is which direction you drive, right? And so a lot of people use a polar system in their head because you use your house as a center point or wherever you're most often at, and then you just extrapolate from there. So the polar system has a lot of things. But we're going to look at Cartesian. We're going to talk about an ordered pair. So we list the x-coordinate first and then the y for a 3D graphs, which you'll be doing. So this would be your x, this is your y, this is your z. If you have a point up here in space, you're going to list x, y, and then z. Okay. And so the order does matter. That's why it's called an order pair. Sometimes you have this, sometimes they're not ordered and it doesn't matter, but that's not usually for graphing. That's usually for set notation. 0, 0 is the origin. And so let's just quickly look at this. So when it comes to quadrants, you're going to label, you go quadrant and then you go counterclockwise. So this is quadrant 2, this is quadrant 3. You use Roman numerals to define your quadrants. This is quadrant 4. When you're in 3D space, they're called octants, and you're going to do 1, 2, 3, 4, and then you're going to make z negative, and then do 5, 6, 7, 8. Okay, so it's just done the same way. It's just negative to that. Here we're going to label a bunch of stuff. We are not going to label every single point. so this has 0, 0 distance in the x, 4 in the y. So this is 0, 4. Here, a point like this is 6 in the x, 2 in the y, so we're going to have 6 and 2. Let's do one of the negative ones. So this is negative 5 in the x, negative 6 in the y, so minus 5, 6. That's good enough. We'll label the origin now. So this is 0, 0, or the origin, right here. It's always found in the middle. Yeah, I'll take advantage of copy that down. We're not going to fill out the rest of the points. If you need practice filling out the rest of the points, just after class, we can do that. If not, don't worry about it. All right, let's talk about the distance formula. This is going to come up all the time in engineering, and calculus, and physics, and everything. It's the distance between 2 points is you take 1 point minus the other point. So here we're going to do x, and you do it coordinate by coordinate. So if you were doing it in 3D coordinates, you would just add plus z2 minus z1 squared. So if you did it in 3D coordinates, that's what we're doing. We're not doing 3D in this class, so we'll just leave that off, but just so you know. So the distance between these points is this. Now, does it matter which one I declare A or B? And the answer is no, because I'm squaring it, okay? Yeah.
Bless you.
So, that reminds me, I need to do something. So here, and so at the midpoint, you're going to add them up and divide by 2. Notice here, if I somehow, for some reason, did x1 minus x2 squared plus y1 minus y2 squared, this would give me the exact same answer as this one. So as long as you always keep the first point first and the second point second, well, however you choose your points, it doesn't matter. You'll get the same distance, because here, if I go from A to B, and I traveled, say, 3 meters, it's going to be the same thing if I go from B to A. That's also going to be 3 meters. If it's not, you're talking to, what's the old, what's the bad joke people say? Is like, when I was your age, I walked up here, I walked in the 6 feet of snow to school, uphill both ways. I'm like, well, that's not quite possible unless you went to home somewhere higher every time, right? So this will always be that. So it's always the same going from one way to another. I guess you could technically break that if you went a different route, but we won't get into that. So it doesn't matter order as long as you always have them in the same. As long as you always have the first one, as long as you always have them in the same slot, if that makes any sense. So I'm going to do the first two. So let's do this. So the distance here. So distance is always positive. Sometimes you'll have something called displacement. Displacement can be negative. So they are different. So here I'm going to choose this to be my B, this to be my A, just so you can kind of follow along. So it'd be 3 minus 1 plus -7 minus 3 squared. So this distance is equal to 4 plus 100. Oops. So this is 4. This is -10 squared would be 100. So here the distance is just minus the square root of 104. Can I simplify this? Yeah, but go ahead and just leave it as this. That's fine. And I'm pretty sure the online program did that. So for the midpoint, I'm just going to add up the coordinates. So I'm going to add 1 and 3 and divide by 2. And then I'm going to have 3 and then minus the 7 divided by 2. And if I do that, I'll get 2 minus 2. All right, here, let's do this again. The distance here would be -2 minus 0 squared plus 0 minus 2 squared. And that just gives me the square root of 8. And I'll say square root of 8 units is the distance. I haven't defined what the units are in this case. And then the midpoint would be 2 plus 0 divided by 2. So 2 plus 0 divided by 2, and then 0 plus 2 divided by 2. And the midpoint is a point. So you do need to have something as 1 comma, as an x comma y. Okay. All right. So go ahead and try to do C on your own real quick and put the answers in the chat. Just so I see you do something. All right. I do want you to try at least some math today, so give that a try. And put in stuff so it's easy for me to fill out once I get the right answer from you guys. Anyone find the distance? Over 34. Yep. Okay. So yeah, a couple of you got it. Anyone get the midpoint? So here to find the distance, we're going to have 2 minus a -3, so that'd be +3 squared plus 5 minus 2 squared, so that's 25 plus 9, so that is square root of 34. And for the midpoint, it'd just be 3 plus 2 divided by 2, and then 2 plus 5 divided by 2. So I have -1/2, and then 7, 2. Yep, that's correct. All right. So the graphical equation of x, a graphical equation is this in x and y is a set of all points that satisfy the equation. So when we graph the equation, what we're drawing on the graph is all the points so close together they look like a continuous line of everything that satisfies the equation. The intercept, so the x-intercept is where the graph intercepts the x-axis, so we set y equal to 0. And the y-intercept is where the graph intersects the y-axis, so we're setting x equal to 0. So let's do these. All right, so here we're going to just do this by plotting points. And then we're going to find the intercept. So here I'm just going to do, we're just going to make our life easy. We're going to do 3, 2, 1, 0, -1, -2, -3. And we're going to do the same. Oops. We are going to do the same here. 3, 2, 1, 0, -1, -2, -3. So we're just going to do the middle points real quick. Zoom on in. All right, so when x is 3, what is y? Well, here I can make my life a little bit easier and have 3x. I can have y equal to 2 minus 3x. Just solve it for y. So here, I plug in 3, it'll be 2 minus 9, so that'll be minus 7. If I plug in 2, it'll be 2 minus 6, so minus 4. And then you can just continue to do this at 0. Of course, it's 2. And then we'll have 5, 8, and 11. And so no matter what your equation is, you can always graph it just by choosing some x and choosing some y. And then here, so our points are going to just be the points smashed together. So it'll be my x, then my y, 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 and then my x, y. And then to graph a line, you only need 3 points. You technically only need 2 points, but it's nice to use 3 just to make sure you did your math correctly. And so I'm going to use this one. I'm going to go ahead and use the 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go ahead and use the 2s. Yeah, using the 2s will be okay. So this will be 2. So 2, 4, 6, 8. So that'll be way up here. And then the 2 will be minus 4. So it'll be down here. And notice here, through the magical skill, yeah, I can draw a perfectly straight line. Okay. And what these arrow means is when we draw these arrows, it means this continues beyond this. I'm just only drawn a section of the entire graph. So that's what the arrows mean. All right, so the x-intercept. So let's do the y-intercept. That one's the easier one. The y-intercept is where we set x equal to 0. So where x is equal to 0. We already calculated this. This is 0, 2. The x-intercept. How do we find this? Well, we set x equal to, we set y equal to 0. And so if we set y equal to 0 in our equation, here we have 0 equals 0 equals 2 minus 3x, and we want to solve for x. If we solve for x, we're going to get x equal to 2/3. So it would be 2/3 0. And notice that's where right here, that's right where it intersects the x coordinate. Or the x-axis. So here, the x-intercept, the y-intercept. Let's do this again for this graph. All right, so here, as we plug it in. So here when x is 0, we'll get -1. When x is 1, we'll get 0 because we'll have 1 squared minus 1. And we'll have 2 squared, which should be 4, minus 1 would be 3. But notice here, if I have -1 squared, it's going to be the same as -1 squared is 1, which is 0, and -2 squared is 4, minus the 1 gives us 3. So these end up mirroring each other, as you suspect they would. So let's go ahead and graph that. So it would be here, here. Oh, let's go ahead and plug in all the points here and then here. And then it is there we go. Oops. That's good enough. Okay. All right. So what do we have here? And notice you can have symmetry. So here we can have symmetry across, this is symmetrical across the y-axis. Okay. And so this is symmetric across the y-axis. So here, what's on this side of the y-axis is the same on that. So we call this symmetry. I think that it shows up in some of the homework questions. You can have different sorts of symmetry. You can have stuff symmetrical across anything. Basically, what symmetry means, if you put a mirror down, and in physics, this is what they use to represent a mirror, as a straight line with a bunch of hash marks next to it. So if I put a mirror here, it will look the same looking at it this way than if I just didn't have the mirror there. So that's what. Here, let me just fill this in just for completion's sake. 2/3, 1, 0, 0 minus 1, -1, 0, -2, 3, -3, 8. All right, our y-axis is this one, our y-intercept. So y-int. I'm going to start abbreviating it. Be 0 and -1. Where does it intercept the x-axis? We actually have it on this one. We actually have. So this we don't have to solve for it. We just found it by happenstance. So it is 1 and 0 and -1 and 0. Notice if it's a function, you're only going to have one x, you're only going to have one y-intercept, but you may have multiple x-intercept if it's truly a function. Okay, I'll leave that up for 1 second as you guys write it down, and then we'll do our last two and call it good. Not to be confused with being similar or congruent, I assume. Yeah, so yeah, that's those words will mean different things in different contexts, and so here we use symmetry specifically to say that if you made, if it's symmetric across the y-axis, it also means it's what we call a even function. That means if you plug in -x, you get the same thing if you plugged in positive, the same positive value. Okay, we'll talk about symmetry in greater detail later. So this is just kind of like a little preview. All right, so let's do this. The absolute value of x. Let's just do this one quickly. We're not going to. Hi. All right, so the absolute value of x, we're going to do 3, 2, 1, 0, 1, -1, -2, -3. Well, the absolute value of 3 is 3, 2 is 2, 1 is 1, 0 is 0. The absolute value of 1 is 1, 2, and 3. One, 0, and 0, -1, 1, -2, 2, -2, and 3. So if I was going to plug those points in, it'd look right here. And then if I graphed it, whoop, there we go. All right, so it just looks like a V. Okay, so the absolute value is the distance of a thing is from the origin. And so that's the correct way of saying it. Some things I will just make it positive. I mean, that works in most cases, but every now and then that can get you in trouble. So the correct definition for the absolute value is distance from origin. Okay. Here the x-intercept and the y-intercept are the same thing. They're both 0, 0. Okay, so these don't actually have to be different. They both intersect at the same thing. It is possible to have a function with no x-intercept and no y-intercept. All right, so let's talk about equation of a circle. Leave that up. Let me zoom out just because. Let's talk about an equation of a circle. So an equation, a standard equation of a circle at h comma k is the centered at h comma k is x minus h, y minus k, h squared divided by radius squared. So here, if you're given a weird looking thing of this and you want to put it into a standard form of a circle, you complete the square twice. And let me show you how to do that. So if they hand you a nasty equation, you're going to move over your x's, and then you're going to leave a blank spot. You're going to have your y squared plus 2, no, this one's minus 6y. And then you're going to have a blank spot. And then you're going to move the constant term over. So be minus 7. So what I did here is I just moved the x up here, left me a spot, move the y over here, and then move the 7 over. So that's all I did. Then I'm going to complete the square. To complete the square, you take the middle part and divide by 2. So negative 2, or so 2 divided by 2. So this is my b. You add b over 2 squared, right? So here, b divided by 2, so 2 divided by 2 is 1. 1 squared is 1, so I add a 1. If I add a 1 here, I add a 1 here. Okay. Here, I have negative 6. Negative 6 divided by 2 is negative 3. Negative 3 squared is a positive 9, so I add a 9 here, and I add a 9 here, because if I add a 9 on one side of the equation, I have to add it on the other. Now, I can simplify this to x plus 1 squared plus y minus 3 squared. So I completed the square for the x and the y. So that basically how to put something into a circle into standard form as you complete the square. Equals minus 7 plus 1 plus 9 would be 3. And the way I did that in my head is 1 plus 9 is 10, minus 7 is 3. So the center here, so this is a circle centered at negative 1, 3. And the radius, please be very careful here. The radius is equal to the square root of 3. Remember, this is r squared, so take the square root of this. Okay. All right, I'll leave this up for a second. We'll graph 2 equations and we'll be done right on time. So again, in order to put a circle into standard form, write your x's on one, write your x's, leave a spot, write your y's, leave a spot, and then put your constant on the other side. Complete the square. Go from here. If it is an ellipse, you do the same thing. It's just you'll have some number here, right? You'll have some a here and some b here. And then you just solve it. You complete the square, you solve it, and then you move some terms around. It's not that much different. Though I don't think that will come up too much, so I'm not going to worry about it. All right, so let's do this. All right, so let's graph the following circles. All right, so here, let me write down what the center is. The center of this circle is 0, 0, because I have nothing here, nothing here. The radius of this circle is the square root of 9, aka 3. So how I do this is I usually put a mark for my center, and I count over, and I count to the right 3, 1, 2, 3, put a dot. Count up 3, 1, 2, 3, put a dot. Count over 3, 1, 2, 3, put a dot. And then count down 3, 1, 2, 3, put a dot, and then try to do it the best that I can. Okay. Now, technically, if I was using Photoshop, I would just grab this little ellipse tool right here, and I just go whoop. But you won't have that in life, so we're not going to do that. All right. Back to my pen tool, or my pen brush tool. So here, I want to find the center. So the center here is what? Well, it's positive 2, because remember it's minus h minus k. So this would become negative 3. So we positive 2, negative 3. So here I'm going to wander over to my circle. So I put a little dot right here to signify that. My radius here, my radius is equal to the square root of 4, which is equal to 2. So I'm going to go over 2, 1, 2, up 2, to the left 2, and down 2, and then just try to draw that the best I can. There we go. That's it.